Okay, so hi guys. Today I'll tell you how computer architecture work. So right now I have my Python compiler with me. So supposedly I write here Python code for addition of two numbers. Now y to 3000 and z equals to x plus y. Now if I'll print z, so it gives me 5000. So this is a Python code for addition of two numbers, but then how it runs inside a CPU is what I'm going to tell you now. So I'll show you the picture of it. So yeah, here this is like a CPU till here. This is complete CPU, ALU, controller, PC, MAR, MBR, AC, IR. These are a part of CPU. Now this is the memory where you're storing everything, or whenever you give command to computer, everything gets stored here. Now these are the address bus, data bus, which I just told you. These are the things that help CPU and memory to exchange information or exchange data or anything. So what happens is once you have made a command, these all happens, the things which I'm telling you right now happens within milliseconds or seconds. So right now I'm just telling you in detail, but this is not how it slows it goes, but just to let you explain it, I'm showing it to you. So what is this is ALU, it is like arithmetic and logical unit. So whatever commands you give to a CPU, for example, addition, subtraction, multiplication, anything or any logical command that you gives to CPU, it happens inside the ALU. Now controller, what it does is this controller takes care of reading, writing, taking addresses, decoding it. So this is what is the role of controller. The decoder here is it decodes. Supposedly we give command of addition to a CPU, so it decodes it and let CPU know what the command is, because CPU doesn't understand if you like write add 2 plus 3 or add 2000 plus 3000. CPU won't understand it in this language. It takes the help of controller and decoder to understand it. Now these IR, PC, MAR, MBR, AC, these are all registers. So what registers are? These are high speed processing units or high speed storage units. In this, these are the storage units, and they store data or addresses or anything for a very short amount of time, so that the CPU could store it and perform any task that has been given to him. So, and this is the memory. So, right now, supposedly we write at 2000 x equals to 2000, y equals to 3000, and then I'll show you how it's done. So this is how the CPU architecture is. So these are the commands which I just gave to CPU. Now the CPU will load the command first. Then I have given the command to add those two units. Then the CPU will add those commands and then he'll store it again in the Z. So this is the complete memory formation or memory management, how the things that we gave to the CPU will store. Now supposedly we gave the command for, now what this PC does is this PC will take the command in a sequential format. So right now the first is we have to store x equals to 2000. So this is the load that this is the CPU is loading all the things that are instructed to him. So right now, he'll store the address. What PC does is PC stores the address of the next command that has to be executed in the CPU. So it stores temporarily the address of the next command that has to be stored. So right now, these are the addresses. So PC will take the address from here and it just stores it, because the first command that has to be done is load. So now the PC will pass the command to MAR, and the MAR stores the address of the command that PC has sent to him, and then the PC will again take the command of the next step, that is like addition. So now once it is with the MAR, so MAR will let us know, will supposedly this address is given to MAR. Now what it does is it sends the address back to the memory and stores it in a uh, location. Now it will what help will it do is once it stores the address to a particular location, now the CPU will can read the address and data from that location, and it helps CPU read the data or whatever the instruction is there written in the at that address. So once the MAR once now the MAR will transfer the address. You could see that this address is one way transfer. So MAR can transfer the data to the memory, and it's just that he could store it on the memory location so that the CPU could read it. Now the CPU after this, now this is what the first is. These are the things. These are the first steps in an instruction cycle. Now after this, fetching phase comes. Now what fetching phase is? Now CPU will fetch the address from here and read the data and give it to MBR, because MBR works on the data bus. So it transfers all the data or whatever it is to a particular location. Now let's see what the next step is. Now the CPU has given the command to read the data. Now the data has been read from here, and it has been uh, once the data is read, now the IR will or the data see MAR sends the address to location, then the CPU sends a read command and it reads the data. Now the data, whatever it is been sent to MBR. Now the MBR has the data. Supposedly the data inside is load 0x330. This is just the command execution command. So now the data inside is being given to MBR. These all are temporary addresses, or the temporary data is stored in it. Now MBR, now what this instruction is, we have to decode it. So MBR transfer its data to controller unit. Now the controller unit have it. Now the controller unit will decode it and see whatever the data is there. So now once it is done, now the controller unit, once it decodes the data, it again sends the read signal to that location and see, and sends the actual data which is being given. Now the data was x equals to 2000. 2000 is being sent to again back to MBR through the data bus, and so this is the execution command. Now what the execution is, the final command is x equals to 2000. We just have to store that. So what AC does is AC stores the result of whatever commands the CPU executes, or the output of the command. So MBR gives it back to the AC, because this load phase of this is completed. So MBR sends the data 2000 back to AC. Now the second command. Now the second command is, now the PC will move back to the second phase. As it is moving in an execution order, it will go to add. Now all the steps will be repeated again. What happens is PC stores the data of the next command, which is like this. So it sends it to the MAR. Now MAR will send the address to a memory location so that the controller can read the address and execute the command. So after MAR sends the address to a memory location, the controller unit or the CPU sends a read signal here and sends the data back to sends the data address, add this to MBR. This is after, now MBR have this add 0032, and it sends it to controller unit here. Now the controller unit decode it and see that now we have to add 3000 to it. So now the again it sends a read command, and whatever the data inside this address is, so supposedly there is now 3000 is written here, so it sends the data here. Now the MBR, now we both have to add all these two things, 2000 and 3000. So the command is not completed yet. So what the addition and subtraction on any logical unit is done under ALU. So MBR sends the 3000 data in ALU, and also the AC also sends the 2000 here, because arithmetic, we right now have to perform a addition task, and which is done under the ALU unit. So once these two things are done, now what happens is, uh, just a second. So what happens is, once these two things are done, ALU will perform the addition of these two things and send it back to AC. Now the AC will have 5000 written here. Now this command is done. So now PC will again back takes address of this command and then sends it to MAR. MAR sends the address to memory location. Now then the controller unit takes reads that location and stores the data whatever inside that location is written. So it sends this address of storing it in Z to MBR. Now MBR sends it to the controller unit. Now the decoder decodes it and performs a read task and say that this store Z, we have to send the result to store. So AC sends the 5000 value to MBR because MBR is the one that sends or receives that data from CPU to outside the CPU or to anywhere. So AC sends the result of 5000 to MBR. Now the MBR has a 5000 written here. Now the task is next to store it to this place. Now there is this Z axis, Z equals to x plus y. So now this unit is for z. So MBR sends the data and send it here. Yeah, then the memory will have a 5000 written some here, like here. Now I don't have it written here, but then you could understand. So MBR will send the data and return here. So now all the three tasks has been completed, and the CPU after this, the CPU task is completed and the memory will have written 5000 over here. Now whatever the after that we have to perform with Z, then it's if we write any other task, then the memory will again perform the same task in the same order. So this is what happens inside a memory or happens inside a CPU if you perform any task to your computer. This is how the perform task happens inside the CPU. So yeah, this is what a computer architecture looks like when you perform anything inside a computer. Yeah.